Hello, and welcome to the first uRTcmix tutorial video. This covers the use of RTcmix inside the Unity game development VR and AR engine. RTcmix is a computer music language that allows all kinds of generative and algorithmic compositional capabilities, signal processing, and synthesis. For more information, go to the rtcmix.org website. For specific information about RTcmix inside Unity, go to the website listed second in this slide here. All right, let's get started. So what I want to cover in this video is how you instantiate the uRTcmix package, get it set up so that you can use it in Unity. And we're going to make a very simple thing that just plays a short beep. So this is the first of these tutorial videos of uRTcmix I'm doing, so it may be a little bit scattered, but hey, that's life. So I'm assuming that you've downloaded the uRTcmix.unity package. Simply grab it, drag it into your assets. And it shows you all the things it's going to import. We'll talk about them in a second. Say import. Everything should be fine, but notice that we have generated an error. Unsafe code requires the unsafe command line option to be specified. We are using pointers inside our C and C++ RTcmix libraries, and Microsoft and Visual Studio and C# doesn't like that. Here's how you clear the error. Go down to your Edit menu, Project Settings, Player. And this may already be open, but the Other Settings kind of tab. Click on that, and down here, obviously other people have had to do this, there is the Allow Unsafe Code checkbox that you can simply check, and that will then work. Okay? So now, let's take a look at what's inside our uRTcmix sort of folder. We've got a couple of folders here. Libs contains the libraries that run RTcmix. You'll never have to touch those. They're just loaded in on Windows or OS X. Prefabs we'll talk about in a second. The README is simply a script that tells you what's here. And the scripts are the RTcmix script components for the prefabs that actually run RTcmix. So let's go ahead and get it set up. Go to our prefabs, and we're going to take this one called RTcmix main, and we're simply going to drag it up here and instantiate it in our game object hierarchy as a game object. This has all the functions that we need to run RTcmix. And in fact, we're ready to run it now, and we can verify that by bringing up this beep prefab, which is a very simple game object that all it does is play a 8.7 second long sine wave beep at the G above middle C. So if we hit our play button, it'll compile the script, and we'll hear our beep. You can see the sound being generated over here by the script. And after 8.7 seconds, it will stop. Okay. So rather than just looking at that, I thought we'd go through the process of actually building that object, and you can see what's involved in creating a working RTcmix component. So let's take it out of our object hierarchy, deleted it, and let's create a new game object. We can make it a cylinder, a sphere, or something. Let's just make it an empty object, and we'll call it beep2. Highly original, I know, but that's what it's going to be for now. So we're going to add some components. First of all, we're going to add a script component, and we'll call it beep2. This is where we'll put the RTcmix functionality. And also, I don't know if you noticed with the beep object, we have to designate it as an audio source because it is in fact producing audio. So we have to add a component that is an audio source. This tells Unity that audio will be coming from this game object. Okay. Now we're set to work on our script. When it created it, it put it out in the main assets sort of folder. We'll just leave it there. Double click on it, start up our Visual Studio editor, and it will load it with the kind of generic game object script that Unity creates. Comes up in a second here. There we go. Loading it in. Very soon we'll see the beep2 script. Yep, there we go. And you'll see that what it gives you by default is just a very simple sort of class definition with the start method and the update method. So we're going to add some things right off the bat. First thing we're going to add is a little tricky. It's an integer variable that we're going to call objno, and we're going to set it to be 0. What this does is this designates which RTcmix process is covered by this script. RTcmix kind of runs in parallel with Unity game objects, although the processes are associated with game objects. For each game object, each unique RTcmix process has to have a unique object number. Now this gives RTcmix some capabilities of communicating with other processes and keeping track of things. For now, just bear in mind, every time you create a new RTcmix game object, you'll have to reset that to another number. They don't have to be done in ascending order. They can be done in any order. But again, bear in mind, no two RTcmix processes should have the same number. Otherwise, it will cause bad things like trying to compute twice as many samples, things like that. Okay, next thing I'm going to do is declare a public variable of type RTcmix main, and that variable is going to be named RTcmix. And I'm going to talk about that more in a bit. Final thing I'm going to put up here in our global declarations is a variable that's a Boolean variable that I'm going to call didStart. I'm going to initially set that to false. This is going to prevent us from trying to compute sound before the RTcmix process is initialized, because that will crash the system. Okay. Well, the first thing we want to do then is initialize RTcmix. So we'll take that RTcmix variable we made, and we'll call the init RTcmix method on it. We're doing that in start because this happens when the game starts. So the only thing it needs to know is which object number we're initializing. Once that happens, we're ready to go. We can now tell didStart that it can be true. Now, to compute sound samples, we're going to go down here and we're going to instantiate another method that's included in this sort of mono behavior class with a weird name of onAudioFilterRead. And it gives you two parameters, an array of data and then the number of channels. This array contains or will contain the sound sample data that we compute. It's about 500, well, it's not about, it's 512 samples, 256 for the left channel, 256 for the right channel. So this function is called very quickly, much faster than the update function. And in this function, the first thing we do is check to see if didStart is false. If it is, then we return and don't do anything. However, if it's true, RTcmix is ready to go, so we can have RTcmix compute some samples by running the RTcmix process. And we give it that array of data to fill with samples. We tell it which object number that we're going to be dealing with, and then we have one final integer here. This is for efficiency. 0 means that we're synthesizing sound only. If we were also signal processing sound, we would set that to 1. This means that RTcmix has to compute twice as many samples. So that's just there to kind of keep things as efficient as we can. Finally, we need to fill out the onApplicationQuit method that comes with this mono behavior class, and we're going to set this RTcmix variable equal to null, and we're going to set didStart back to false, so it's all ready to kind of rebuild and reinstantiate itself. Okay, so we're ready to go. However, this won't make any sound because we haven't told RTcmix to do anything. RTcmix makes sound or processes sound and respond to what we call scores. These are strings that contain specific RTcmix commands. So I'm going to send a score to RTcmix with the sendScore command, and I'm going to send it a wavetable instrument command, starting at time 0. Let's make it go for 7.8 seconds this time, with an amplitude of 20,000. That's on a 16-bit scale up to 32,768. We'll say do the F above middle C, and put it in the middle of the stereo spread. 0 is left, 1 is right, 0.5 is in the middle, and we have to tell it which object number it's doing that to. So now this should, when we start the game, call this start method. It'll initialize RTcmix, send our score, and then go down here and start cranking the samples. Okay, let's do it. One final thing we have to do. Remember that I declared that RTcmix main variable as a public variable. Notice that over here a little slot has opened up. The beep2 object and these components have to know about this RTcmix main because that's where all those functions live. So I'm going to simply take this, drag it over here, and put it in. Now there's also a way we can accomplish this in code, but I'm not going to talk about that in this tutorial. But at this point we should be set. Beep2's got its script and audio source components. RTcmix main is all set there. So if we hit play, we should hear our F above middle C. There it is. Okay. For 7.8 seconds, we've now created a working RTcmix game object. We'll cover other things in future videos, and thanks for watching.